In this video, we will learn all the formulas you need to know to excel at your GCSE. If you want to improve at your math skills for your GCSE, click the link in the description of the video to access the MDX Tutors website, where you can get in touch with us to prepare for your GCSE with a highly qualified tutor. We will begin with the geometric formulas, starting with the area of a rectangle. If we're given a rectangle with bases b and height h, then its area is given by the product of the bases with the height. For example, if the measures are 6 cm and 2 cm, then the area of the rectangle will be 6 times 2, which is equal to 12 squared centimeters. Similarly, as two triangles form a rectangle, the area of a triangle is given by 1/2 the product of the base with the height. In the case where the base measures 4 cm and the height is 3 cm, its area is 1/2 4 times 3, which is equal to 6 squared centimeters. For the trapezium, we need a bit more information. We need the length of the long and short side and its height, and the formula to calculate its area is 1/2 the sum of the sides multiplied by the height. For example, if the height and short side measure 12 cm and the long side measures 22 cm, then using these values in the formula, we get that the area of the trapezium will be 1/2 times 12 plus 22 times 12. 12 plus 22 is 34, so 34 times 1/2 is 17. So the area will be 17 times 12, which is equal to 204 squared centimeters. The area of a parallelogram is very similar to that of a rectangle. All we need is the bases and the height, and the area will be the result of multiplying these two values. For example, if the basis measures 8 cm and its height measures 5 cm, then the area of the parallelogram will be 8 times 5, which is equal to 40 squared centimeters. For a circle, all we need is its radius, and the area will be given by the formula p times the square of the radius, where pi is the very well-known irrational number. So in the case where the radius is 5, the area will be 5 squared times pi, which is 5 times 25, and that gives us 78 times 53 squared centimeters. To calculate the length of a circumference of a circle, that is the length of this red line, we have to multiply pi times the diameter of the circle. So if the radius again is 5 centimeters, its diameter will be 10 centimeters. And so its circumference will be pi times 12, which is equal to 31.4159 centimeters. Continuing with circles, if we take an angle theta and draw the two radius that generate it, then we can calculate the length of the arc segment. In this case, it would be the red line. For this, we need the radius of the circle and the angle theta. This length is calculated with the following formula: 2 pi times the radius times theta divided by 360. It's a bit complicated, so let's work with an example. Suppose we have a circle of radius 5 and we take theta to be 50 degrees. Then the length of the arc formed with this angle is 2 times pi times the radius, which is 5, times theta, that is 50, divided by 360. Using the calculator, we get 4.363. Now, let's move on to calculating volumes. If we have a prism, we will need the area of the section that forms it, which in this case is a triangle, it could be a circle, or it could be any shape we want. The volume will be the product of the area of this section times the length of the prism. So if we call A the area of the section and L the length, then the volume of the prism would be A times L. For example, when the section is a triangle with bases 6 cm and height 4 cm, we can calculate its area by using the previous formula. This will be 1/2 6 times 4, and this gives us 12 squared centimeters. So now to calculate the volume of the prism, we have to multiply the area of the section times the length. So this is 12 centimeters times 10 centimeters, and this gives us 120 cubic centimeters. Similarly, we can calculate the volume of a circle by calculating first the area of the section. The volume of a cylinder of radius r and height h will be pi times the square of the radius times the height. So for example, if the height is 10 centimeters and the radius of the circle is 4, then the volume of the cylinder will be pi times 4 squared times 10, and this gives us 502.65 cubic centimeters. Here we have a summary of the areas we have worked with in this video. Now let's look at all the things we need to know about polygons. These are two things. The first one is, how do we sum the interior angles of a polygon? There's a simple formula for this, and that is n minus 2 times 180, where n is the number of sides we have in our polygon. So in this example we have 5 sides, 5 minus 2 is 3, and 3 times 180 is 540 degrees. So this is the sum of the interior angles for this polygon. And another very important property they have is that when we add an interior angle plus an exterior angle, this sum is always 180. And it's very easy to notice this just by looking at the picture. Now let's study rectangle triangles. The first important theorem about them is Pythagoras' theorem, which states that the sum of the squares of the sides is equal to the square of the hypotenuse. A squared plus b squared is equal to c squared. So we could be asked to calculate c given that the other two sides are 3 centimeters and 4 centimeters long. So using the formula, we have that c squared will be the sum of the squares. So 3 squared plus 4 squared. This is 25 centimeters squared. But this number is c squared, and we were asked to calculate c. So if c is 25 centimeters squared, then c is equal to 5 centimeters. We can also study the trigonometric ratios, also called SOHCAHTOA. We have different ratios between the sides of a triangle, and we call them by these names: sine, cosine, and tangent. The sine is the ratio between the opposite angle and the hypotenuse, given that we are standing in one angle called theta. The cosine of the angle theta will be the ratio between the adjacent side and the hypotenuse. And the tangent of the angle theta will be the ratio between the opposite side and the adjacent side of the angle theta. So for example, if we are asked to calculate x, the hypotenuse of a triangle, with theta being equal to 30 degrees and the opposite side to this angle being 5 centimeters, then we have to look for one of these 3 trigonometric ratios that relates the opposite side, the hypotenuse, and the angle. And this is given by the sine of theta. So we know that the sine of 30 will be the opposite side, 5 centimeters, divided by the hypotenuse, x. So we can isolate x, which will give us 5 centimeters divided by the sine of theta. And using a calculator, we get that x is equal to 10 centimeters. Similarly, we can be asked to calculate x, where x is now the adjacent side to the angle theta, given the angle and its hypotenuse. Now what we have to do is use one of the trigonometric ratios that relates the hypotenuse, the adjacent angle, and the angle. and this is the cosine. So we will know that the cosine of the angle 30 is equal to the adjacent side, which is x, divided by the hypotenuse, 8. And so isolating x, we get that it's equal to the cosine of 30 times 8 centimeters. Using a calculator, we get that this is 6.9 centimeters. And now let's move on to more physical things. If we have to calculate the density of an object is a measure of the ratio between the mass and the volume of the object. So, for example, if the mass of a solid is 200 grams and the volume of the solid is 40 cubic centimeters, we can be asked to calculate the density. And for this, we know that the density will be equal to the mass divided by the volume. The mass is 200 grams divided by 40, the volume. And so 200 divided by 40 is 5, and the unit will be grams divided by cubic centimeters, because those were the units for the mass and the volume respectively. We can also be asked to calculate the speed of an object, and the speed is a measure of the distance divided by the time. So if a car is traveling at 448 miles and it takes the car 8 hours to travel that distance, we can calculate the average speed of the car. Using the formula, we get that the speed is equal to the distance, 448 miles, divided by the time, 8 hours. And this is 56 miles per hour. Very similarly, we can calculate the pressure. The pressure is a measure of the force divided by the area where the force was applied. So if a solid exerts a force of 3,500 Newton on the floor, and the area of the solid in contact with the floor is 5 square meters, we can calculate the pressure exerted by the solid on the floor. Using the formula, we have that the pressure will be the force divided by the area, and that is 3,500 Newton divided by 5 square meters, which is 700 newtons divided by square meters. And newtons divided by square meters is another unit called Pascal. So this is equal to 700 pascals. Now let's see more advanced mathematical formulas. If we have a line that joins 2 points x1, y1, x2, y2, and we want to calculate the coordinates of a midpoint M, the coordinates will be given by the formula. In the x coordinate, it would be x1 plus x2 divided by 2. So the sum of the x coordinates of each of the 2 points, and the y coordinate of the point M will be y1 plus y2 divided by 2. So again, the sum of the y coordinates of the 2 points divided by 2. For example, if the points were 1, 2 and 3, 5, then M would be calculated using the formula as 1 plus 3, the sum of the x coordinates divided by 2, and 2 plus 5, the sum of the y coordinates divided by 2. 1 plus 3 is 4, divided by 2 gives us 2, and 2 plus 5 is 7, divided by 2 is 3.5. So the coordinates for this middle point will be 2 and 3.5. If now again we have a line that joins 2 points, we can calculate the gradient of the line. And this is calculated by using the ratio between the change in the y direction divided by the change in the x direction. So the change in the y direction would be y2 minus y1. And the change in the x direction would be x2 minus x1. So if the points are 1, 2, and 3, 5, like before, the gradient will be this ratio, and that is 5 minus 2 divided by 3 minus 1, which is equal to 3 halves. And this is very useful, knowing the gradient of a line, to study functions, linear functions. These are functions of the form y equals m times x plus c, where m is the gradient. So, for example, if we draw the plot of y equals to 3x plus 1, 3 would be the gradient. And if we look at the plot, we see that the change in the y-axis is 3, when the change in the x-axis is 1. So 3 divided by 1 is 3, and that is why the gradient is 3. And to continue with linear functions, we can see that if we have parallel lines, then they have the same gradient. Parallel lines are those that never meet. For example, here we can work with the lines 3x plus 5 and 3x plus 1. These two lines will never meet, and they have the same gradient, that is 3. And when we have perpendicular lines, they have the opposite and the inverse gradient. So if one of the lines is 3x plus 1, the gradient of the other line, of the perpendicular one, will be minus 1/3. So it's the opposite with the minus sign, and the inverse with 1 over the gradient of the first one. So it's minus 1/3, while the gradient of the first one was 3. Another useful formula is the one needed to calculate the interest. We have two types of interest. The simple one is I equals P times R times T, where I will be the interest, usually the value we want to calculate, P will be the initial investment, R will be the interest rate, and T the time, which usually it's calculated in years, but it could be another unit. So for example, if we want to calculate the interest of an investment of £100 at a 5% interest rate for 2 years, all we have to do is calculate it with the formula. It will be 100 times 0.05 times 2, and this equals to £10. The other interest we're interested in is the compound interest. In this case, each year a certain rate will be added to the account where we already had the money. So we will be calculated by repeatedly adding the interest to the known amount. So if we have a starting amount of P and the interest rate is R, and then it's the number of periods, which could be years, months, minutes, then the new amount will be P, the starting amount, times 1 plus R over 100 to the power n, because we have to repeatedly add the rate of interest to P. That is why we have the power n. And the 1 plus the rate over 100 is due to the fact that every time we are applying the interest, it is being applied to P plus whatever interest we had gained previously. And now for a more mathematical formula, we will work with the law of indexes. There are a few rules very useful for working with indexes. The first one is what happens when we have two numbers, m and n, and we want to calculate a to the power m times a to the power n. Notice here that the basis a has to be the same for both numbers. So in this case, when we have the product of powers, then the powers are added and we get a to the power m plus n. When we have a division, something similar happens, but instead of adding the powers, they are subtracted. The power of a power, so a to the power m, and that number to the power n, is the product of m times n. Every time we take a number and take the power 1 of that number, we get the same. And the power 0 of any number is always 1. Also, the powers are distributive with the division. Having a negative power gives us the inverse of a number to that power. And a fractional index can be written as a surd, which is what we will study now. These are the laws of Surds, and they're actually very similar to the ones of indexes because every Surd can be written as an index. What's useful here is knowing how to perform calculations like number 5. When we have a division of the square root of a number divided by the square root of another number, we don't like having square roots on the denominator. Therefore, we take the same number and we multiply it by the denominator over itself. So this number is 1. Any number divided by itself is equal to 1. So that's why we have this equal sign. And when we operate here, we get the square root of a times the square root of b. Using property 1, we know that this is the square root of a times b. And the square root of b times the square root of b, using property 2, we get that it is equal to b. So we have that the square root of a divided by the square root of b is equal to this other value that has no root in the denominator. And with this, we finish today's video. Remember that if you want to train with a specialized tutor, you can check out the website, which link is in the description of the video.